Good evening, everyone. In this video, we'll be talking about state diagram behavior. Okay, so we'll be looking at effects and activities. Okay, and then we will also be looking at do activities, entry and exit activities. Okay, completion, transition, and how signals can be sent between objects. Okay, so let's look at each and every one after the other. State diagrams would be of very little use if they just described events. Okay, we already have seen. Okay, so how the events basically happen, and then how within a state diagram, how the transition happens between different states. Okay, and mostly what we have seen is we only were describing these events. Okay, a full description on object must also specify what the object does in response to these events. Until now, we have not seen that. An event is happening, so the transition is happening from one state to the other one. Okay, but what shall we do? Okay, so what the object does in response to these events, these things also need to be described properly. Okay, an effect is a reference to a behavior that is actually executed in response to an event. Okay, so if an event happens, okay, so an effect is a reference to the behavior that is executed. And an activity is the actual behavior that can be invoked by any number of effects. Okay, so an effect is a reference to a behavior, okay, that is executed in response to an event, and an activity is the actual behavior that can be actually invoked by any number of effects. Okay, so think about this example. Say, for example, once we are putting the phone, okay, so on the hook, okay, so the on hook event will be executed. Okay, that means you have to come back to the idle state. But when you basically put the on hook, so in the background there can be one activity which is happening. So the disconnect phone line. Okay, so the phone line will change to idle state, which we have seen in the state diagram earlier. But the point is disconnect phone line is the activity that is executed in response to an on hook event. Hope that is clear. Of course, we will be checking at several examples about these activities. An activity might be performed upon a transition, upon the entry or exit from a state. Okay, so when you basically come into the state or when you go out of the state, or upon some other event within the state. Okay, and we will be checking at all these things in detail in the coming slides. Activities can also represent these sort of internal control operations. Okay, such as setting attributes and generating other events. Okay. Such activities have no real world counterparts, but are mechanisms for structuring control within an implementation. Think an example. A program might increment a counter every time an event occurs. Does it have any meaning in the real world counterparts? But it is an implementation specific, and then it has to happen. Okay, this is basically for structuring the control. So notation for an activity is the slash followed by the name. Okay, so think in this case say for example it is in an idle state. Okay, so something. Okay, and then when you click the button, say for example the menu is visible. So basically you are moving to the state when an event occurs, which is the right button is down on a keyboard, on a mouse. Okay. But when you basically display that one, the activity is happening here is, so when the right button is down, okay, so on the mouse, when the right button is down, so it will basically display this pop-up menu. Okay, so you are still holding it, so the menu is actually visible. So basically when the right button is down, you are displaying the pop-up menu. Within the menu, when you are in this state, okay, so there can be several other events which are happening. Okay, say for example the cursor is moved when we are moving the cursor. Okay, so basically we are highlighting the menu item. So right button is clicked, and then you are basically moving, you are holding it like that. Of course, when the right button is up, okay, so the pop-up is gone, and that's what is happening here. When an event occurs, so the right button is down or up. Okay, so certain activity is actually happening. There can also be these sort of do activities. Okay, A do activity is an activity that continues for extended time. So earlier we have seen like an event is happening and then like it basically does certain activity. Okay. The activity is like a pop-up window and then like the pop-up basically goes out. Okay. So that is the state diagram which we have seen in the earlier slide. But a do activity is a continuous activity. Okay. So it basically continues for extended time. Say for example, look at this one. When a paper jam happens, that is in the state. So the do activity is like flash warning light. Okay, so as long as like the printer is in paper jam state, okay, the do slash basically like the warning light, the flash warning light will continuously happen. So this is the activity which you can actually represent by these do activities. But these do activities can occur only within a state. They cannot be attached to a transition. Okay, we have to remember that one. Okay. So the way like here we are seeing the example, the paper jam is a state. In that state, like it is basically flash warning light is happening, and that is the do activity. So the do activities can include, they can be like this sort of continuous operations, the way like I have given this example. But they also include like, say for example, like the sequential operations that actually terminate by themselves after an interval of time. So certain activity is performed, okay. Some operations basically go on, okay, sequentially, okay, and then like once they are terminated, okay, they can be terminated after a certain time. Okay, so two activities can be of the both types. Okay, one which actually continuously runs are like say for example some sequence operations they basically perform and then like they terminate themselves. Okay, but you are still in that particular state. You have to remember that. Okay, unless like another event generates or like another transition happens. So the notation we have already seen, like it basically has this do slash, okay, denotes this do activity. That may be performed for all or part of the duration that an object is in its particular state. That's the example which I have given earlier as well. Okay. So if it is a continuous state, if it is a continuous activity, so then like basically it will be running until you are in that particular state. That is like the printer jam state. Okay. Or else like say for example as the sequence activities execute and then like it these things basically finish, but you may still end up in the same state. If that is the case, like then this do activity is not performed for the full life of a state. Okay. So part duration like it is happening. But these do activities may be actually interrupted by another event that is received during its execution. While you are executing this do operation, another event may basically come. Okay. But such an event may either may terminate this current state and then like actually we may have a transition where like we move to another state, or sometimes it may not cause the transition to happen. Okay. Say for example, think about the example like if the transition is happening, okay. So what sort of events may come in the middle? Say for example, a robot is actually moving. So the moving is the state, and all of a sudden, say for example, like it encounters some resistance, some obstacle is lying there, and then like the robot is actually moving, and it basically has come in contact with that bar. So then what happens? The robot seizes. Okay, it's moved. It cannot move anymore. So some resistance is there. Something is obstructed. Okay, that's an event which has actually happened in the middle. So the do activity is actually it is moving. Okay, and in the middle like this resistance has come. Now it has actually moved to a different state, which is like say for example, C is moving. So it is not moving at all. Okay, it can be a different state. Okay, it can be designed as a different state. Okay, that's about the do activities. Then the other types of states are like see other activities are these entry and exit activities. Okay, instead of showing activities on transitions, okay, the way like I have given you the example. Okay, so while we are discussing the transitions, okay, and also like say for example in the earlier slide like I have given you the activity on a transition. Okay, instead of showing the activities on the transition, we can actually bind these activities to entry or to exit from a state. Okay, so there is no actual difference in express power for both the notations. Okay. Let me give you an example. Okay, so this is like an automatic door which has to be opened. Say for example in your garage or something. Okay, So you basically press the button, like then the door basically closes. Okay, you press the button again, like it will basically try to open. Okay, so that like when you are basically trying to get your car out, or like you are putting your car in. Okay, but for safety purposes, like say for example, if the door is opening and if you press the button, it will continue to open. So it has to fully open before you can actually close it again. That's for the safety purposes. Say for example, like if the door is getting closed, all of a sudden like something has child has fallen in the middle, or like something has fallen in the middle. So you immediately press it and then like it basically opens. It's a better idea to be safe so that like it completely opens and later like you can send the next signal. Now the point is like if you want to design that one as a state diagram. So the door can be in closed state. Then say for example if you depress that button, okay, so the motor will be off. So that means like it will move to this, this transition happens and the door is in the opening state. So basically like the garage door is opening. So during the opening state, like say for example, whatever you do, like it will be in that opening state only. Okay, even if you press or something, because there is no image for that. Okay. So once the door is fully open, okay, so you are in the opening state, and then like once the door is fully open, the motor will turn off. Okay, so that's what the event is, like door is fully open, the activity is motor is turned off, motor is off, and then like you move to this sort of open transition, open state. See, you were in the closed state, and then like you press the button, it has immediately transition happened to the opening state. Okay, and then like once the door is fully open, like you are moving to this sort of open state. The activity there is like the motor is basically up and then like the motor is basically off. Okay, in that particular these are the activities for that. Okay, during that particular transition. So now once the door is open, like if you press the button again, then the motor will basically down again. This time like the door is closing. Okay, so it is in this sort of closing state. But anytime like if you press it again, then it will immediately, the motor will turn up. Okay, that is the act which is happening, and you immediately move towards this opening state. So while the door is actually closing, like if you press the button again, it will immediately move to this sort of opening state, and then like it will open, the door will open full, and then only like you can close it again. That's for the safety regulations. Assume like that is for the application. Mostly it will happen like that. It will open like that. Alternatively, like if it is in the closing state, and then like if the door is fully closed, then the motor is off again. Okay, and then like basically like the door will be closed. So the motor is basically taking up or down, or like it has to close or off. Okay, so that is the close is off. So this is where like you are actually showing all these activities onto the transitions. Okay, so you are basically showing all the activities on the transition. There are alternate ways. Okay, so that's what I was talking about. So instead of showing them with this sort of activities, instead of showing on these sort of transitions, we can bind these activities to these sort of states. Say for example, now let us try to design the same example with an entry. The activities are associated with this sort of entry or exit to that particular state. So the same thing, okay. So you can be in the closed state, okay. When you have basically entered this particular state, okay, that is the entry slash, you basically represent it like entry slash, motor is off. When you are in the closed state, like motor is off when you enter that state. But when you basically press that button, depress, you will be moving to the opening state. In the opening state, when you enter the opening state, the motor will start going up. Okay. So then, say for example, if the door is fully open, you will move to the open state. When you enter the open state, the entry slash, so the activity there is like motor is off. Got the point? So basically, like the same way, like we had this sort of transitions, now we have all those activities associated with the state. Okay, and once you are in this open state, so if you press the button again, okay, so you basically like you are closing it. Okay, so you are in the closing state, And in the closing state, like once the moment like you enter into the closing state, like the motor is basically turning down. Okay, so the door is getting closed. Okay, from up to the door. Okay, but again the same model, like if you press the button in the middle while it is closing, like it will be moved to the opening state and it will be fully open. Similarly, like if the door basically closes, okay, so then you will actually move to the closed state. So that means like the entry, the moment you enter this sort of closed state, like the motor will be turned on. So in theory, both these things are exactly the same. There is no difference between these two diagrams, actually, state diagrams. Okay, but why do you do this? I mean, like you can ask like why you will be following, putting the activities to an event. I mean transitions or to this sort of states. So the example is also like basically talks about that. Say for example, if there are multiple transitions which are actually leading to this sort of same state, and all of them will do the same activity. Okay, say for example in this case, the depress here from this one. Okay, so from the closed state to the opening state, or like closing state to the opening state, the activity is the same, isn't it? The motor is the activity which is happening. Now the point is like if there are multiple transitions, you have to put the activity for each and every transition. Rather like you best put the transition, I mean that activity to that particular state, okay, as an entry state. Okay. See what we are doing. We don't have to write this activity every time. Okay. So if all transitions into a state perform the same activity, it is concise to attach the activity to the state. That's one of the advantages by moving with this sort of putting the activities to the state. So just like the entry state, you can also have the exit state. Exit activities are less common than entry activities, but the thing is like you will still represent by this exit slash the activity. So whenever a state is exited by any outgoing transition, the exit activity is performed first before you actually have the transition. Okay. So if there are a lot of activities associated in a state, okay, in a transition, in which order like these activities will be executed? First, like the activities on incoming transition will be executed first before you actually come to this particular state here. Okay, so the activities on this incoming transition will be executed first. Then the entry activities within that particular state. Then the do activities within the state will be executed. Then the exit activities. Then the activities on the outgoing transition. So this is the order in which like the activities will be executed. The events that actually cause transitions out of a state can actually interrupt these do activities. So while the do activity is happening, like some of the events may happen which actually cause the transition out of the state. Okay, and the do activity will stop in the middle. But the interesting thing with this sort of exit activities is, even if the do activity is interrupted and you are moving, basically the transition is happening, the exit activity is still performed. Okay, so check this order. Okay, the order of activities. The do activities, even if they terminate in the middle, like it will basically have this sort of exit activities which will be executed. And of course, like the activities on the outgoing transition will be executed, will continue further. Okay. Other than these do activities, I mean, like, see, the do examples which, I mean, like the two things, like two different types of activities which happen are like these entry and exit activities. Okay, and of course, like the do activities. These are not the only things which are possible. There are several other types of activities which are also possible. In general, any event can occur within a state and cause an activity to be performed. Entry and exit states are only two examples of events that can actually occur. We have discussed them in detail in the previous slides. But say for example, see in this sort of closed state, so there can be an event like a shutdown event, okay, which will basically trigger an activity like motor off. Interestingly, like self transition also works. Okay, so basically, like if the menu is visible And if the cursor is actually moved, okay, highlight menu item, but you will be still in this sort of menu visible state only. So this state diagram we have seen in the beginning. So this is like a self transition. But interestingly, when you have this sort of self transition state, okay, both the entry and exit activities will still be executed. Every time, like you are basically transitioning, self transitioning to the same state, still the entry and exit activities are executed. Okay, that's about other events. Now let us look at this completion transition. Often the sole purpose of a state is to perform some sort of sequential activity. These cases appear pretty often. Okay, so when the activity of a particular state is completed, that a transition to another state fires immediately. So a state is basically, you came to the state, it is basically doing this sort of sequential activity, it is doing certain activity executions. Okay, once it is finished, once the activity is completed, it basically immediately moves to this sort of next step. So a transition is fired. Okay, in such a case, like you don't have to put another event for that one, because like the activity is within that particular state. Once the activity is finished, like you will basically, the transition is fired. Such sort of transitions are called completion transitions. Okay, so in a state diagram you will not put any event name for such a transition, but of course like you can still put the guard conditions. Okay, but there is a catch here. So if you put only the guard condition without even a transition name, of course, because it is a completion transition, a guard condition is actually tested only once. So this we have discussed when we were discussing this sort of guard conditions themselves. Guard condition is tested when the event basically occurs. They will not be checked continuously. But if, say for example, pick a situation, if a state has more than one completion transition, and if there is a guard condition which is actually turns out to be false, then you basically cannot move out. Of course, if you have multiple completion transitions, like you will have several other transitions may happen. Okay, but if all of them have guard conditions, and then like if nothing is satisfied, the state remains active and it may be stuck there. That's a problem. So basically, like the guard condition will not be checked again, because like the completion event basically will be generated only once, isn't it? So the activity is finished, so that actually generates the completion event. So it will not come the second time. So if none of these sort of guard conditions are satisfied, okay, so it will basically get stuck there. So of course, like when you basically model such a state diagram, you can actually use this special condition which is called else. Okay, so else to basically apply, like if none of the conditions basically works. So if everything else basically says false, okay, condition is false, so then you can basically take this transition, the else transition. Okay, that's about the completion transition. Then another very interesting concept is an object can perform the activity of sending a signal to another object. Okay, so for example, within a system, like there are several objects. Okay, so in this case, like the button is one object. Okay, so where you are pressing the button, looking at the same garage example. So button, when I press the button, like it is actually sending the signal to the particular object. So which is like the door. Say for example, like which is opening or closing in that particular state. So object performs the activity of sending the signals to another object. So it is pretty common. A system of objects basically interacts by exchanging these signals. Okay? So that's how the systems work. So the activity, so its structure is like this: send target dot s. Okay, this is the signal, and you can basically send certain attributes to this one. Okay, so this basically sends a signal s with given attributes to the target object. The target is the target object here. So the target object can be a single object, or like it can be multiple objects. Say for example, with one activity, okay, so you can send the signals to multiple objects. If the target is a set of objects, each of them receive a separate copy of the signal concurrently at the same time. Okay, Then like once the signal is received, each object basically processes the signal and determines whether to fire a transition or not. Okay, that particular object's like state transition basically happens. So basically once the signal is there, it has to basically process and then it has to basically decide whether to fire a transition or not. But there is a small catch here. The objects can actually receive signals from multiple objects. Okay. Say for example, if multiple objects are actually sending signals to a particular object, the order in which these sort of concurrent signals are received may actually affect the final state. So these are actually called race conditions. Probably like you might have discussed this already in the operating systems. Race conditions are a big problem, especially in concurrent systems. Okay. So basically like in which order like these signals comes actually decide like what will be your final state. Think about this example. The door may or may not remain open if the button is pressed at about the time the door becomes fully open. If the door is fully open, okay, and at that time like if the signal comes, okay, so basically then the door should already start closing. But the point is like if it is few seconds before the door is fully open, even if you press it, it will keep on opening and it will remain open. So in which order this basically signal comes actually decides whether the door is open or left open or like it already starts closing. Okay, these are race conditions. Concurrent systems frequently contain race conditions. Okay, these things are to be avoided to the extent possible, and they can be avoided by careful design. Okay, so your design should be basically considering these things as well. So with this one, like more or less, we have finished chapter 5 of object-oriented modeling and design with UML. Okay, thank you very much for your attention.